Alright, let's make this way less intimidating. When people hear that computers use binary, it sounds mysterious, almost like some secret machine language that only experts understand. But the truth is, binary is actually one of the simplest ideas in computer science. Everything starts with just two symbols, 0 and 1. That's it. And from those two tiny choices, computers build everything: text, music, images, games, video, all of it. So let's break it down step by step and make binary feel easy. So, what actually is binary? Binary is a number system that uses only two digits, 0 and 1. That's why it's called binary, because there are only two choices. Now compare that to the number system we use every day, which is decimal. Decimal uses 10 digits, from 0 to 9. Binary use only two digits, 0 and 1. Computers love binary because they operate effectively with simple yes or no states, offering two distinct possibilities. So already binary is not weird, it's just a very simple two-choice system. This is where it all begins to make sense. Computers do not think in English or in any other human language. They work with tiny electrical states. At the hardware level, something is either on or off. That physical reality matches perfectly with binary. 1 means on, 0 means off. Binary is not random. It's a direct reflection on how computers physically work inside. That's why binary became the foundation of digital technology. And honestly, you already understand binary thinking because real life is full of two states examples. The light can be off or on. The door can be closed or open. The answer can be no or yes. The switch can be down or up. That is exactly the same kind of logic binary uses. So binary is not some alien concept. It's just a system built on two simple possibilities, repeated again and again. Now let's introduce one important word, bit. A single 0 or 1 is called a bit. Bit is short for binary digit. And one bit stores just one tiny choice. Alone, that seems very small. But when bits start working together, they become incredibly powerful. So if you remember one thing here, remember this. One binary digit equal one bit. That's the smallest building block. This is where binary gets more interesting. The more bits you have, the more combinations you can make. With one bit, you get two possible values, 0 or 1. With 2 bits, you get 4 possible values. With 3 bits, you get 8 possible values. Every time you add one more bit, the number of possible combinations doubles. That's the pattern. More bits means more information, more possibilities, and more things a computer can represent. Now let's talk about how binary numbers actually have meaning. Each position in a binary number has a value. And from right to left, the values double each time. So the pattern goes 1, 2, 4, 8. And then later it would continue 16, 32, and so on. So when you look at a binary number, you don't read it like normal text. You think in place values, from right to left. That's the key skill for converting binary into decimal. Let's try with a real example. What does 1010 mean? First, line it up with the place values. 1, 2, 4, 8. Now match the digits 0, 1, 0, 1. That means we only add the place values where there is a 1. So we add 8 plus 2, and that gives us 10. So 110 in binary is equal to 10 in decimal. That's the method. Find the ones, keep their values, and add them together. Let's do one more. What does 1101 mean? Again, line it up with the place values. 1, 2, 4, 8. Now look at the digits. 1, 0, 1, 1. We keep only the values under the ones. So that gives us 8 plus 4 plus 1. That is equals 13. So 1101 in binary is equal to 13 in decimal. Same rule, same pattern. Once you understand the place values, the whole thing becomes much easier. Now here is the cool part. Even though computers can show you photos, music, videos, text, and games, inside the machine, all of that becomes patterns of zeros and ones. Different kinds of data, same binary foundation. So whether you are typing a message, watching a video, playing a video game, deep down, the computer is still working with binary. And that's what makes binary so powerful. So where does binary actually show up? The answer is everywhere in digital technology. Text relies on it. Images rely on it. Audio relies on it. Games rely on it. Every digital device depends on binary behind the scenes. You may not always see it directly, but it is always there, doing foundational work in the background. So let's lock the main ideas. Binary uses only two symbols, 0 and 1. A bit is one binary digit. Each position in binary doubles in value, and computers build everything from these patterns. So binary is not scary. It's just simple choices repeated. And that's why binary is the base language of computers. And that's the real magic of computer science. Huge digital worlds are built from tiny, simple rules. Just 0 and 1. What looks complicated on the surface often begins with something surprisingly small and logical. And binary is one of the best examples of that. Big systems, simple foundation, that's the beauty of it.